Hi everyone, I am Miryam de Lhoneux and this talk is about low resource NLP with a primary focus on dependency parsing and what we can learn from it generally. I want to start with this figure which represents language diversity in the world, where each of the dots represents a language and roughly where it's spoken. And we all know that NLP does not cover much of that. In fact, we've been focusing on English for a very long time and this is only beginning to change. However, it is changing at a relatively fast pace, as we can see from this figure here, which shows the increase in number of ACL papers or ex-ACL papers that contain cross-lingual in their title in the past 15 years. And a big development has been the development of MBIRD, multilingual BIRD, which is a huge language model pre-trained on a lot of languages without any cross-lingual supervision. It's just trained to do language modeling on a lot of languages. And this model has shown surprisingly good performance on a lot of NLP tasks in spite of the lack of cross-lingual supervision, which seems to indicate that it is learning some aspect of multilinguality without needing the supervision, which also can give us an impression that multilingual NLP is solved. This is relatively easy to do and we don't really need cross-lingual supervision. Well, I don't think this is quite the case. In fact, the paper that I just mentioned found a very strong correlation between the percentage of overlapping subwords between languages and transfer performance. And we can see in this figure this correlation, and we can see that for some languages like Japanese here, Chinese, Japanese here for dependency parsing, Chinese here for NER, our models perform really poorly. So we're not quite done. And this is, there's been a lot of studies showing that transfer works best, for example, between typologically similar languages in MBIRD. So it's not quite as easy as we just train one huge language model for lots of languages and we're done. So in this talk I want to ask this question, so where are we at then? What is the status of multilingual NLP? And I want to start by looking at the data. Okay, so what data do we have in multilingual NLP? This is a representation of one of the most popular multilingual dataset, XNLI, a natural language inference multilingual dataset. And as we can see, this is clearly better than using only English, but it's not extremely typologically diverse. There is a few Indo-European languages and just one other. And an additional problem of this dataset is that it is actually translated from English and the annotation is ported to these other languages, which means that this is actually not data that is directly occurring in the languages, so it is clearly not ideal. And the same is true for XQuad, another popular multilingual dataset for question answering, which also has not extremely diverse typological diversity, although maybe a little bit more than XNLI. A dataset that does much better on typological diversity is this TatoEBA machine translation dataset, and this is great. However, it uses web crawl data, and the recent study has found serious problems with some of the web crawl data that is included in this dataset. With for some languages, there is basically no data that is actually linguistic. So the situation is pretty bad for some languages. One dataset that started out as not extremely diverse is Universal Dependencies. We can see that this was the first version, and this was very highly Indo-European biased. However, the situation has really improved in the last few years, and this is not even the latest release, and it keeps growing with more variety. And the advantage of universal dependencies is that this is actually data occurring directly in these languages, and that have been typically manually annotated by typically native speakers or linguists. So the situation of universal dependencies is clearly better than for any other multilingual dataset in NLP. Now, I have to admit that even universal dependencies is not, if you take the whole set of tree banks and look at frequencies, it is not, it is still heavily Indo-European bias, as you can see from this figure displaying the number of tree banks per language family. And if we look at the number of words per language family, this the situation is even more dramatic, and the bias is extremely strong. This means that maybe this dataset is not really quite ready to be used as training data for all of these languages. However, we can use it for evaluation, and I believe we should. So what I'm really trying to say here is that I believe that with universal dependencies, dependency parsing is ahead of the game in terms of low resource NLP or typologically diverse NLP in general, and we can ask questions about universal dependencies parsing that are relevant for the rest of NLP. For example, we can ask the question of can transfer learning mitigate the language technology gap between high and low resource languages. We can also look at the usefulness of using typological features to mitigate this gap. So in this talk, I'm going to try to summarize what we've learned so far from asking these questions in dependency parsing in the last few years. But before I do that, I would like to briefly mention other datasets initiatives, which here don't have a claim of multilinguality in the sense that they don't claim to make datasets that cover a lot of typological diversity, but that actually instead are trying to fill much needed gaps in general in NLP. For example, there's the two first here are datasets for African languages, and Africa has a lot of language diversity and is notoriously underrepresented in NLP, so these are really welcome additions. And these other datasets are also for machine translation for indigenous languages from the Americas. I'm going to get back to this later by mentioning our participation in this shared task, and also machine translation for Indic languages. And this is really opening new opportunities for NLP in general. So now let's look at low resource dependency parsing, and again, more specifically, we are interested in the question of if transfer learning can help mitigate the language technology gap between high resource and low resource languages. And we're going to try to answer this question in the context of dependency parsing. Now let me just do a brief recap of what transfer learning is. So typically in machine learning, we have a task or a domain A and a task or a domain B. So in the context of parsing, this would be different languages, and we typically create a model for each of those tasks or domains, and here languages. And in the context of transfer learning, what we do instead is to create just one model, either from the two tasks that is then applied to the two tasks, or it can be a model that is built from one task, typically the source task, and we're transferring the knowledge to another task, typically the target task. And this has been applied quite widely to dependency parsing. First, it was applied in a very simple way. This work here simply concatenated pairs of tree banks annotated with universal dependencies. And they found that if you do that, you actually don't decrease LAS so much. You could expect that the LAS would decrease, but it is not the case. Depending on the pairs, it can even increase LAS. Now, in this work, they trained the parser not just on pairs of languages, but on 7 different languages, so 1 parser for 7 languages, and found that this parser also performs well and even outperforms monolingual baselines if you include a representation of the language in the input of the neural network parser. Now, in our own work, we found that sharing the parameters of a neural network parser works really well for related languages typically with or without this language representation. But if you share too much of this network and train a parser on a pair of unrelated languages, then it can hurt parsing performance. In another of our own studies, which was our participation in the Canal 18 shared task, we found it beneficial to train parsers on clusters of quite closely related languages. So typically a Scandinavian cluster, for example, including Swedish, Danish, and Norwegian, perform really well. But if you train on languages that are a bit less related, like for example even just French and Italian, it is not as beneficial. And a lot of work has built on this idea that you can train parsers on related languages and use different techniques to transfer the knowledge from related languages. And this is 3 examples that obtain really good LAS improvements from using various techniques such as data augmentation or polyglot training, where you train 1 parser for multiple languages, etc. So following up on all of this, we asked the question, can we actually train a parser that performs well on a lot of languages? And for this, we did not want to use language relatedness, but rather just use large pre-trained language embeddings and cross-lingual word embeddings. And we asked the question, can we train a parser on a training set and then test it on a disjoint test set? So we basically in a 0-shot setting, and we utterly failed. And this was only using BiLSTMs. Now, pre-trained language models have changed that game. One of the early papers that tried using large polyglot language models pre-training in the same vein as MBERT, but here it is not MBERT. They trained their own polyglot language models, and they found that this is very beneficial for low resource dependency parsing. And in the same kind of work trend, this is, as far as I know, the first paper that used MBERT and trained 1 parser based on all of the UD tree banks. And this parser performs quite well in the 0-shot setting for low resource languages, and does not really underperform so much on higher resource languages. So you do lose a little bit of accuracy, which is expected for high resource languages, but not as much as you would expect. So this has really changed the game, and there's been some follow-up work like this one trying to analyze how MBERT can be used in the context of 0-shot dependency parsing, where the 0-shot means you have not seen treebank data for the language. And they found that this works really well for some languages, but it still remains very poor for others. Now I would like to take a step back and ask the question, what does 0-shot actually mean? Minimally, what is required typically in papers for a setting to be qualified as 0-shot is that you have not seen any data for the task for the language. So here, treebank data for whatever language you're testing on. And typically, a difference is made between if you've seen the task at pre-training time. So in the case of mBERT, if you've seen it in mBERT, and typically these two are differentiated. But here I would actually like to propose that maybe we should have a more fine-grained definition or categorization of what zero-shot is, given the success of transfer learning for related languages. So what I suggest is that we should also take into account if the genus of the language has been seen for the task. So for example, you've seen a Germanic language, maybe this helps you. And same for pre-training. It's different if you have not seen any of the any data for the genus, and same again for language family. You might have seen the language family task data or pre-trained data, and if you have not, then this gets trickier. And another important category is if you've seen the script in the task, so here tree-bank data, or at pre-training time. Now I would like to see what this categorization can do when analyzing results of dependency parsing in a zero-shot setting. So I'm going to look at the baseline of this paper here, which I will come back to this paper later. And so the baseline uses mBERT and trains a parser on 13 tree banks with the idea that to cover as much language diversity as possible. As you can see, it covers quite a few language families, and the idea is also to cover different scripts. And now from this paper, I took a language, so that was tested in the zero-shot setting, but I took a language for each of these categories and look at the LAS score. Now this table should be taken with buckets of salt. So these results are cherry-picked, and there should be more systematic analysis done, which is not straightforward. Some of these categories are mutually exclusive, but some are not. But in general, I think there are some interesting things in these results. For example, you can see, so the case of Belarusian is really the minimal required for zero-shot parsing. That is, the parser has not been seen tree-bank data for the language, but it has seen pre-trained language model data for Belarusian, and it has seen a Slavic language in parsing. And as you can see, the LAS score is really pretty high for a zero-shot setting. Now, if we look at Kazakh, which is a little bit more difficult because the parser here has not seen any language data from the genus of Kazakh. So it goes already a bit lower, and then Yoruba has been seen as a language model pre-training, but has not been seen in parsing, and the language family has not been seen in parsing. And as you can see, the performance is already quite a bit lower, but it's still relatively okay, given that we don't have much data about this language. Now, I think this result here is also interesting. So Faroese has not been seen in pre-training data, but the parser has seen a Germanic language in its tree-bank data. So the LA score is quite decent, actually, for a zero-shot setting again. And now we're getting in problematic territory. So if we have not seen the genus or the language family, neither in tree-bank data or in language modeling data, then the performance is really poor, and not seeing the script is really leads to really catastrophic results, which should not be surprising. What do we really expect from trying zero-shot parsing on an unseen script? And another study here that I cite here has found that transfer learning failures can be really largely related to script, and they saw that transliteration can mitigate this problem. So this is one potential solution. So now to summarize this section on transfer learning for dependency parsing, again we asked the question, can we mitigate the gap between high resource and low resource languages using transfer learning? What we found by asking this question in the context of dependency parsing is that it seems surprisingly easy to transfer knowledge to related languages. Parsers trained on with different techniques on related languages perform really well, even in the zero-shot setting. We found that using pre-trained language data helps a lot. So if you have seen the language in mbert, you can have a parser that performs quite well. But if you have not seen the language family or genus data, either at pre-training time or for the task, then the performance is really poor, and basically the performance of such parsers for these languages is really poor. And really, actually, the majority of world languages don't have related languages that are high resource. So we're really actually not covering that many languages if we think of this that way. And also we've seen that if we haven't seen the script, then the performance is also really, really poor. So we definitely have to do something about that. And here I want to ask the question if we've been overestimating the benefit of transfer learning by mostly considering languages that are low resource but that have a related language that is high resource. And the danger of this overestimation is that it can justify this sort of tendency to focus on English first and to have multilinguality as more of an afterthought, and as the idea of adapting our models to other languages. And maybe this pushes more to taking multilinguality into account from the start rather than as an afterthought. Now I would like to move to the question that I mentioned again in the beginning of the talk: can typological features mitigate the language technology gap between high and low resource languages? So I'm probably preaching the choir here in this workshop, but we all know that typological features cover many more languages than languages we have tree-bank data for. This is just an example of one feature in the World Atlas of Language Structure, the feature of whether languages have no tones, a simple tone system or a complex tone system, and we can see that this really covers a large set of languages. And if we could use these features in parsing, we could maybe cover a lot more languages and start really mitigating this gap. And obviously this technique, this question has been asked quite early on. Actually, the first work that I'm aware of that tried to use typological features in dependency parsing dates back to 2012, where the results looked quite promising, but they've been applied since using universal dependencies and using neural-based dependency parsers, and the results have been a little bit more mixed, which might indicate that the baseline is now stronger or might indicate other things. But there is some limitation in how it has been used in these different studies, typically in the resources needed to apply parsing to low resource languages, where they needed typically pre-trained word embeddings, which means that this work has mainly tested in languages for which we have some data and that kind of simulated a low resource language, a low resource setting that is maybe a bit overestimating or underestimating how difficult low resource languages can be. And more recent work has tried this for languages for which there is really few resources, and found some improvements from using typological features. And this is again the paper that I mentioned earlier that did zero-shot dependency parsing. So again, using MBERT, 13 languages, and they used an adapter to incorporate typological features. Now, as we can see, although the results are pretty consistently improving, the overall gain is still not extremely extensive, and it's not enough to mitigate the gap. Going from 45.2 to 46.2 gives you still a parser that is relatively useless. And I think that this question is far from being answered. There's still a lot of room for improvements in these techniques, and I personally think that we might not get away with the idea that the parser can really just implicitly learn what it means for a language to have these typological features, but we'll have to be more explicit about what it means, and maybe combine our neural systems with rule-based systems that give constraints on word order properties for different languages based on these typological features. And this is work that I'm planning to do in the future. Now, in the last part of this talk, I am going to talk about low resource NLP beyond parsing, and more specifically, I will talk about our submission to this shared task, which is happening here at NACL, and the idea was to translate Spanish to these 10 languages here. And as you can see, this is a really truly low resource setting in the sense that training data is very scarce for most of these languages, with Quechua being slightly exceptional here. And these languages are not really related. We can see that only 3 languages belong to the same language family, which makes it more difficult. And the last difficult aspect of this shared task is that all these languages have quite rich morphology, which is notoriously difficult in NLP. And this is a representation of roughly where these languages are spoken. So we participated in this shared task, and of course when we signed up for it we expected a challenge. Of course we also did it for that. We wanted to get our hands dirty and see what happens in a really difficult scenario. But yeah, we were not quite prepared to how difficult this would be. We tried some obvious things, pre-trained transformers, using back translation and character level NMT, but all of this basically without any success. And in the end, we actually ended up submitting just our baselines with a very reasonable baseline, which is a phrase-based model. However, only doing white space tokenization, which really you can expect this to be a very low baseline for morphologically complex languages, because a lot of word forms will not have been seen, of course. But we also tried a character-based random babbling baseline, and there we're really just building kind of a language model, and we're not even conditioning the translation on the source sentence. So really this was meant to be a very, very low baseline. So how did we do? Well, obviously we did not do well at all. However, we did not as bad as we expected compared to other teams and also other baselines. So let's first look at the baseline. The baseline provided by the organizer is based on pre-trained transformers, and you can see here the blue scores are extremely low. Now, of course, blue scores have known problems, and particularly for morphologically complex languages, but the character F-score gave quite similar trends. So I will only show blue scores because I believe the community is more familiar to them. So we can see the blur scores of the baseline are extremely low. And we would expect our random babbling baseline to be even lower, but it is actually not for all languages. And as I said, we submitted the system and it was not ranked last unexpectedly. So this really shows how difficult this task is if even a baseline that does not take the source sentence into account does not perform really poorly in comparison to other systems. The SMT baseline did much better than that. Of course, the scores are still very low, but they're not that much lower than the best system, which was submitted by Helsinki. It is lower, but for some languages it is surprisingly close, given that, I will remind you, we used white space tokenization and a phrase-based model, which are really expected to perform really poor. So what in our group we concluded about this task is that really low resource MT for polysynthetic languages is really difficult. And take it as you want. I take it as good news that there's really actually still a lot of room for improvement, and that MBERT is not the solution to everything. There's still quite a lot of more fun things to do in NLP. So to conclude, what I would like you to take away from this talk is first, I hope that I convinced you that universal dependency parsing is kind of ahead of the game in terms of multilinguality, and that we can test hypotheses about multilingual NLP in the context of dependency parsing, and hope that they later port to other tasks. I've asked two such questions and looked at work that dealt with them. The question of if transfer learning can help mitigate the language technology gap between low and high resource languages, and we saw that transfer learning works surprisingly well between related languages. So it does mitigate this gap for low resource languages that have a related language that is high resource. However, for the ones that do not have such a high resource language that is related, dependency parsing is very poor, and we also saw that machine translation, for example, can be poor, and I expect in general that NLP is poor for such languages. I suggested briefly that maybe we can use typology, and briefly mentioned work that did that, but also suggested that maybe there's more to do in that area, and I think this is really an underexploited area of research that still has hopefully a lot to offer. And yeah, I've just highlighted community efforts from different sub-communities in NLP for African languages, South American languages, Indic languages, and so on. And they are making it possible to really do truly low resource NLP. Maybe instead of doing English first and having multilinguality as more of an afterthought, as sort of domain adaptation, the time is ripe to start putting multilinguality at the core of what we do. Thank you very much for your attention.